Hi, I'm Steven, and I invented the Unibrau System. Today, I'm going to show you how to program the SV1. The SV1 is a simple PID-based controller. It's a universal voltage controller. It operates in Celsius and in Fahrenheit, and it can be used as a switching controller for heating-only applications or for cooling-only applications as well. So it's quite a versatile little unit in a box here. So the SV1 is a PID controller, and to explain what a PID controller is, it's an acronym, and it stands for Proportional Integrative Derivative, or is it Integral Derivative? Can't remember, doesn't matter. But what it is you're able to it's an algorithm which helps to maintain thermodynamics, and it's very useful for maintaining reservoirs with volumes of water in it. So when brewing with beer, PID controllers manage the temperature in such a way to not overshoot your temperature and just maintain a very consistent, very steady temperature while brewing. So the difference between, let's say, a switching controller, which was our ETC controller, and a PID controller is a PID controller tends to pulse frequently the temperature to maintain temperature, much like an oven, actually. An electric oven maintains the oven temperature. A PID uses a similar algorithm to do that, whereas a switching controller uses a mechanical contact, and it cuts the power like a light switch does. You know, that's a mechanical contact when you switch your light. So because our ETC controller switches power on and off to the element, it doesn't have a brain, you know, like the PID has the algorithm which is designed to manage the temperature. The switching controller, all it can do is shut the contact once the temperature has been reached. And so what we have with thermodynamics is when you're heating water and you cut off the power to the water, let's say at 150 degrees Fahrenheit, that water can continue because it's a mass of water that's rising. Even though there's no more power applied, it'll continue to heat for a period of time after that, and you will get temperature overshoot when brewing with that. Now, with our ETC controller, is that a bad thing? Does it make bad beer? You might be asking yourself, and the answer is no. You're not going to make bad beer just because you've overshot the temperature. However, keeping and trying to maintain accurate temperature helps to create the flavor profiles that we're looking for when we're brewing beer. So in beer brewing, generally PID controllers are favorable, but we're such small batch brewers, a 1 degree temperature overshoot from the ETC controller was never a bad thing. Here I want to show you how to program the SV1 controller. So I'll start by just showing you the display screen here. At the top here is our current temperature, and here is our set temperature. When you press the heat button, it illuminates, and this green button you can see is on. And when you press the pump button, you can see it illuminates as well. So just very simple control. If I want to change the temperature, I just change the temperature like so. I press the set button and it locks it in. So now I'm going to show you how to go into the program mode. So I press that button and we are in the input parameters menu. So that's the main menu parameter. Now to actually change something, we hit the shift button, which is this one here that's got the A and the M on it. And we are in sensor calibration mode, and you can go up and down like so. Okay, we press the set button again, and we are in the digital filtering mode. And again, you can go up and down there. So now there's more information in the included manual if you want to kind of understand what all these different things mean. I'll press the set button, and now we're back in the main menu parameter of input. and we'll hit it again, and now we're gonna control the output parameters, and we hit the shift button to get in there. So it's PID mode right now, and I hit it again. Oops, I mean hit the set button again, sorry. And we are in heating and cooling mode, which is heating mode. So if I want to change it to cooling mode, I can go like so. So you can even control, for example, our cooling control solenoid if you wanted to maintain and manage fermentation temperatures. Okay, so we go back into set, and we're back into that main menu parameter of outputs, and we'll go into alarm programming. There's a bunch of alarms that you can program in here. So you can have a positive and a negative deviation alarm set. Personally, I find it unnecessary. I don't do a lot of alarm programming because I find these just to be very reliable. But it's nice to know that the feature's there for you to use if you want to use it. And now we're back in alarm programming mode. We will go into PID mode, and this is where you can control the control period, the proportional period, the integral time, and the derivative time of your PID. Now, if you want to learn more about that, again, go into the manual. It's just too complicated for me to explain it in a video, but the manual does a pretty good job of explaining it. And then here we can change it from Fahrenheit to Celsius as well. So this controller for Canadians and for Americans alike, and our international customers, we can easily switch that around. And now we're back in the home screen. And that's it. I mean, that's all I can tell you about this controller. I'll just tilt it up. I'm not sure if you can see that, but here's the fuse, here's your heat output, your pump output, your probe, and your power. So just a very super simple, straightforward controller for you to use. If you like what you saw in this video, please leave a comment below. And if you've got any ideas for other videos that we can make for you, we'd love to hear from you. Please share and subscribe. And what else?
That's about it.
That's about it? Okay.
Yeah.
And I'll catch you next video. Thanks for watching.